Hey everybody, Mr. Quick here. Today we're going to be looking at Eureka Math / Engage New York Math, Module 5, Lesson 2, the area of right triangles. Now before we jump into this, let's do a quick refresher. A right angle is one that comes to a 90-degree point. So this line and this line are perpendicular to one another, kind of like you would see in a T or a quadrant, or a cross, or an intersection, right? And you show that it's a 90-degree angle because you have the little squares here that would ultimately form a full square, right? So each of these angles, if you were to measure it, the measure of this angle, 90 degrees. If you were to measure this angle, 90 degrees. This angle, 90 degrees, so on and so forth. So if we have a 90-degree angle, and then we connect these 2 points, this is called a right triangle, because it's a triangle, obviously, 3 sides, that has a 90-degree angle. Now, if we want to find the area of a right triangle, we want to figure out what the inside of this triangle would be, then we're going to use a very specific formula. And that formula is area equals 1/2 base times height, right? 1/2 base times height. And because of the commutative property, you can mix these numbers around. As long as you multiply them, it doesn't matter, right? Like 2 times 2 times 3 is the same as 3 times 2 times 2 is the same as 2 times 3 times 2, and so on and so forth. So it doesn't really matter which order, just remembering that to get the area of a right triangle, it's 1/2 base times height. So you could also look at that as area equals, you could take the base times the height and then divide that by 2. So either way, you're going to get the right answer, because when you multiply by 1/2, that's the same as dividing by 2. Okay, let's look at a couple of examples. Okay, we'll do a pretty traditional one to start out with, right? Here's our triangle. Say this is 15 feet. Say this is 8 feet. We'll say this is 17 feet. Okay, so we're going to have 1/2 base times height to figure out the area of this triangle. We're going to look at the base is this side here, so we have 1/2 times 15 times the height, which is this side, which is 8 feet. Now, I could do it in this order, 1/2 times 15 times 8, but since it doesn't really matter which order you do it because you're multiplying, we can move things around. We can move these numbers around. So I'm going to do 1/2 times 8 times 15. So I'm basically flipping these two. The reason I'm doing that is 1/2 times 8 is easier to do than 1/2 times 15. 15 is not an even number. So 1/2 times 8 gives us 4 times 15. And that would mean our area is 60 feet squared, because it is area, right? So again, we can multiply any of these numbers. We could have multiplied 8 times 15, and we would have got 120, and then 120 times 1/2 would be 60. So it doesn't really matter which order you do it, just as long as you multiply all three. Now what does matter is that you get the correct base and height. So let's look at another example. How's that? That's a triangle. Now, you might normally think, well, shouldn't a triangle be like this so it's easier to look at? It's still a triangle even if it's flipped onto its side. So, this angle here is our 90-degree angle. So the base and the height always come from the 2 sides that make the 90-degree angle. So this side here, we don't need that. So let's say this is 6 inches. Let's say this is 8 inches. And let's say this is 10 inches. The 10 inches in this case is irrelevant, which means it doesn't matter, because we know this is the height and this is the base, because they form the 90-degree angle. So if we're going to say 1/2 base times height, we're going to be looking at 1/2 times 8 times 6. 1/2 times 8 is 4. 4 times 6 is 24 inches squared. So the area of that right triangle is 24 inches squared. Okay, let's look at another example here. So this is a right triangle. We have our 90-degree angle. We know the base and the height are going to be these two sides that form that 90-degree angle. So we're looking at area equals 1/2 base times height. And when you say 1/2 base, that means 1/2 times the base. Okay, so if we say 1/2, and we'll put these in parentheses just so it's easier to keep them straight, times the base, which is 8 2/3, times the height, which is 5 3/5. Then, and another way we could look at this is, or to make it a little bit easier to multiply, is we can convert these mixed numbers into improper fractions. So we could say 8 times 3 is 24, plus 2 is 26. The denominator stays the same, so we end up with 26/3. And then over here we have 5 times 5 is 25, 5 times 5 is 25, plus 3 is 28, so we have 28/5. Okay, and now that we have, instead of mixed numbers, we have improper fractions, we can just multiply straight across. So 1 times 26 is 26. 26 times 28 would be 728. And I used a calculator on that just to save us a little bit of time, but you could obviously do 28 times 26 to get that answer. 2 times 3 is 6. 6 times 5 is 30. And then we can see that 30 goes into 728 24 times. 8 left over, denominator stays the same. If we want to simplify that, let's put it over here. We end up with 24, and instead of 8/30ths, we have 4/15 meters squared. Okay, now obviously getting here to here was division, but instead of going through the whole problem, just figured, well, let's go ahead and do that. 728 divided by 30. Let's just do it, just so we can see how we got it. Okay, 30 does not go into 7, but it does go into 72. 2 times 30 is 60. We subtract, we end up with 12. Bring down the 8. 30 goes in to 128 4 times, which is 120. We subtract, we end up with 8. So we have 24, remainder 8. So 24 is our new whole number. 8 is our numerator, denominator stays the same, 30. There you go. So anyway, area equals 1/2 base times height. Doesn't matter if you have decimals, fractions, whole numbers. It's the same formula each time. So we'll talk more about this in class. I hope that helped, and we'll look at some more examples. Thank you for watching. We'll see you soon.